Hi, and welcome to today's video. So today we are going to do something pretty interesting, I'd say. We are going to work with infrastructure as code. True infrastructure as code. If you worked with this concept of infrastructure as code, or YAC, then you probably worked with some YAML files or JSON files, so CloudFormation specific to AWS, or Terraform, which is more cloud agnostic, or maybe something for Azure, ARM templates, and so on. Well, you worked with JSON or YAML files, which are great, so it's definitely better than having to to configure the infrastructure again and again, but it's not actually code, isn't it? Those are more markup languages, YAML and JSON, I mean. However, AWS brought something interesting with this tool, the CDK, so Cloud Development Kit. That's what it stands for. And it's basically an abstraction layer over their infrastructure as code service over CloudFormation, which allows us to use true programming languages to define the infrastructure. So we actually get to program the infrastructure using Typescript, using Python, and other languages, which is great because we can use programming techniques and concepts, and yeah, we can use all the programming goodness that we already are used to when developing the actual applications. We can use polymorphism, we can use inheritance and other techniques. And yeah, so maybe let's try to define an architecture and see how that works. And of course we should, well, try to define or start with an architecture that's pretty well known, widely used. And interesting, I didn't manage to find a proper example of this exact architecture, even though it's widely used. It's in fact the de facto architecture for web applications deployed on AWS. So we have, well, a client, a user, something which connects to the, or sends requests to the application load balancer, or maybe other types of load balancer, but in our case will be an application load balancer, which then forwards the request to an application tier handled by or managed by an autoscaling group, which manages multiple or single or multiple EC2 instances. Then the application tier connects to the database, so we use RDS to manage our database, where it can store the data, of course. Of course, here we can have multiple VMs, it doesn't have to be one. We in fact should have at least two, so it's highly available. If one availability zone goes down, then our application is still running. But even if we don't have multiple, even if you plan to have only one instance, then you should still use an autoscaling group, because that will ensure that in case the single instance goes down, a new one takes its place. So it minimizes the downtime, which is great. Also, regarding the networking and security part, as you can see, we have a VPC, so all the services that we deploy will be inside the VPC. And also we have the public subnets, or public and private subnet. Well, in practice, in reality, the application will also be in a private subnet. That's the most secure way to do it, because it basically, it's impossible to access it and try to attack it from the internet, since it doesn't have a public IP address. However, in our case, we deployed it in a public subnet, so we are able to download the the actual application that we want to run on it, and maybe some other packages and so on. And we need the public IP address for that. There are ways to keep it in a private subnet and then download packages. We can use a NAT instance or NAT gateway, but let's not complicate things more than it's necessary. And of course we can use security groups, which are firewalls that we can attach to each resource in a VPC, and that basically handles the security part for us. We can use, for example, a security group to allow only traffic coming from the application to the database, which is great, and we're going to do just that. So we know what we want to do. Let's do it. If we take a look at the documentation for the AWS CDK, then it tells us how to get started. So we are going to create so right now I'm in an empty directory. We're going to create another directory for the project. Let's call it the de facto architecture, maybe just arch. Okay, let's go into it, and we are going to use the CDK CLI to initialize the app. So we have to tell it to initialize an app. We can also initialize a stack. If we think about NPM, for example, or Node, with Node we can build either applications, so standalone applications, or packages. And the CDK is pretty similar to that concept, in the sense that it allows us to build standalone applications or stacks that are intended to be used by other applications or other stacks. In our case, of course, we want to use or to create an application, then we specify the language. We want Typescript. There are others, but we're going to go with Typescript since I think it's the suggested one. Also the documentation, well, you can change the language in the documentation, but anyway. So let's initialize it. It's going to take a bit of time until it installs the dependencies, so see you in a few seconds. Okay, and the initialization is done. All the dependencies are installed. Let's open it up in VS Code and see what we can do. So that's what the CDK created for us. We have a bin directory, then a lib directory. So the bin is the entry point, let's say. So this is what creates the app, and it uses this stack defined in the lib directory. And this is where we're gonna add our code, of course. So each CDK construct or each CDK stack is a Typescript class or an ES6 class. And yeah, so by default the CDK doesn't offer too many packages, so it only offers only comes with the core package. So we cannot do too much with it, so no EC2 instances, no VPC, no nothing. However, we can do one thing, and that is to define tags. So tagging is a nice and useful concept to use. In our case, we might choose to add tags to our resources to identify the project or the team or something like that. It's very useful for billing purposes to identify the costs and to split them up. And of course, we want all our resources to have maybe the project in our case. Let's say that the project is YouTube and we want to add it as a tag. And we use so CDK tags of this. So everything that we do in a stack happens in a context, within the context of a stack. and in 99% of the time this tag will be just this, so this tag. So yeah, we want to add tags to this stack, and we want to have the tag key should be project, and the tag value should be YouTube, maybe. Okay, now let's add so let's think what we have to do. Well, we have to, first of all, we have to define security groups. Security groups. And these are for, so security group for the load balancer. Hello, load balancer, SG, then app SG, so app security group, and finally DBSG. Why in this order? We are going to see in a moment. So once we have the security groups, we can, well, maybe we can start defining actual resources. Before the security group, we want to define a VPC. Everything that we deploy, remember, happens inside the VPC, the gray box. Cool. After we have that, we can deploy the database maybe. Then we can deploy the application tier, so the ASG and the instances, then the load balancer, or maybe application load balancer, and that should be it. That should be it. Maybe some outputs. We want to see some stuff maybe as the output. So let's start with the VPC. So I'm gonna use the integrated terminal. We are gonna install some additional packages. So besides the core package, if we take a look at the npm package file, you see we only have the CDK core. So let's start by adding additional packages. So AWS CDK, let's say EC2, also AWS CDK, maybe we copy that, RDS, also elastic load balancing, V2. V1 refers to classic load balancer, V2 application and network load balancer. If you don't know about them, don't worry, maybe I'll make another video, or maybe you can check them out. They are not hard to understand. In fact, it's pretty interesting. Okay, besides that, we want what else? We also want auto scaling that comes in a separate package, so that would be the auto scaling group. Also secrets manager, yes, secrets manager. We're going to use that to handle the database passwords for us, and in fact it's quite important. We have to do that pretty early, so somewhere around here. Secret with db password. So let's install those. Okay, so starting with the VPC, let's see. I cannot remember if the VPC comes with EC2 or if it's a separate package. Let's see if we can instantiate it using the EC2 instance, or not the instance package I meant. So let's import everything from EC2. Yeah, nice. And then we start coding. So we define a VPC, new VPC. Okay. Now most constructs will take the scope as the first parameter. As I said, in most cases it's just this. Then an ID, let's give it or name it VPC, and then some properties. Well, and let's see what can we configure? We can configure quite a lot. All of those pretty much have default values, so let's not worry about those. CIDR, we can go with the default CIDR, that should be fine. Yeah, so basically we don't have to provide anything. What's interesting about the default VPC is that it will create both private and public subnets for each availability zone. So remember, we are working in an AWS region. In our case, or in my case, it is Ireland. That's what I use. I'm from Europe, so I need an Europe region, and I choose Ireland because it's the region that gets new features. So it gets first new features in Europe. And yeah, so we have a region which is composed out of multiple availability zones. Availability zones, you can think of them just like more or less data centers that are spread apart. So in case one of them goes down, the region is still working, only with less capacity. Yeah, so as I said, the VPC will create subnets for each availability zone in the region, which is quite nice, both private and public. And we're gonna use them, of course. Now we have the VPC. Let's define the security group. So we're gonna call this LBSG, maybe capital G. Okay, new EC2 security group. Okay, so the scope again, this ID LBSG, that the ID can be whatever you want, it just has to be unique within the stack. Okay, then some properties. Okay, let's see what we can configure in here. So we should provide the VPC, which is the VPC we just created. Of course, we can go for the shorthand notation. Then allow all outbound traffic. Yes, we want that. Yes, we want it. So actually we don't want it, because this is the load balancer security group. Well, I guess it doesn't really matter, but let's say that we don't want that. So the default value is true for this. So every traffic from within the resource is allowed. But let's say that we want full control over what goes through the load balancer, so we're gonna set it to false in this case. And anything else, security group name, yeah, so maybe a description, SG for the facto architecture, or for the load balancer. Let's keep it simple. Cool, we have that. Then we have to configure the egress and ingress rules. So egress meaning what traffic from inside to outside, and then ingress traffic from outside, so from the internet towards the load balancer. So let's start with the ingress rule. So we want to allow traffic from the entire internet basically, and that means we have to define a peer. So in our case we can use some already defined values. So EC2, if we look for peer, yeah, we have it, any IPv4, yeah, so basically any traffic from any IPv4 address. Cool. Then we want the port. Again, we can do just that. So we know we will be working with HTTP, so plain HTTP. You should work with HTTPS, but we don't want to bother with the certificate manager and having a SSL certificate for now. We might do that in a separate video. So let's do just that. TCP, yeah, TCP port 80, so the default or the standard HTTP port. And description, okay. So if we provide a description, allow HTTP traffic for the ALB. Okay, cool. We have that. Then let's add egress. Okay. Again, we want to allow traffic. Well, let's allow traffic on port 80, and that should be it. Yeah. So let's just copy paste that and be done with it. Okay. Now for the application security group, let's do just that. So let's copy this. Okay, we're gonna call it app.sg again. Now for the application, we will allow the default outbound setting, so allow all traffic from inside the instance, meaning that it will be able to download packages and download the application and all that stuff. For the application, okay, cool. And we want to allow traffic coming from the load balancer, and that's it. So the architecture or our applications should be secure by design, meaning that physically traffic should be allowed only for or from known sources. In our case, we know that traffic to the application should be coming only from the load balancer, and in that case we can use the security group to enforce that. So if we take a look at this method, you see it takes an IPR. So basically any class that implements this IPR interface can be used as a parameter in here, and guess what? The security group itself implements that. So if we take a look at the class, so security group class extends the base, which implements some interface, which extends the IPR interface, meaning that we can just reference the security group of the load balancer in here. Let's fix that. Okay, nice. Also, our application will be running on port 3000, so it's not 80, it's 3000, which is fine, from the ALB. Okay, and let's add the database security group. So we're gonna call it dbsg. Okay, db, maybe like that, for the database. And just like before, we are going to allow traffic coming only from the application tier, so only from resources having this security group attached. So we can copy that and basically add it in here, and the traffic will be for Postgres. So our database is a Postgres database, so we have to allow traffic for the Postgres port, which is 5432. Allow traffic, allow Postgres traffic from the application. Nice. Okay, so we have the security groups. Then let's define the secret. This will store the database password. We want to create a secret, basically db secret. So new. Let's see if, yeah, we can auto import it. Already got it. So new secret. The scope, again, this ID. We're gonna call it db secret. Okay, and some properties. So description, encryption key. Okay. So first of all, let's start with the secret name. We are going to use that later. So let's call it like that, db secret. So pretty simple. Then let's tell AWS how to generate our secret. So first of all, we want to well, we can provide a template, a starting template, so a JSON containing some properties to which AWS will add our secret, our password. So in our case, we can do it like this. Yeah, so it takes a string, so we're gonna use JSON stringify to create a JSON string out of our object, which should contain a username. It's just something that we add, so we use this secret to store the database password. We might as well store the username next to it, and then username would be Postgres. Maybe let's define that up here, db username, so that would be Postgres. Okay, we can use that. Okay, nice. So that gives us the starting point. Then let's exclude some characters to not mess up with the export. We will see that later. So we want to exclude that. Anything else we can provide in here? Include space, generate strings key. Yes, we have to tell AWS or Secrets Manager to which key the value, the generated password, should be assigned. And of course, we want to store it in the password property. Okay, so we have the secret. Now let's define the database. Maybe we import it up here. So let's import as RDS from RDS. Okay. Did that const RDS new RDS. Maybe db new RDS. And we have a bunch of options in here. Remember, RDS contains common databases, so Postgres, MySQL, MariaDB, and so on, and the AWS specific one, Aurora. And there is a slight difference between them. So the classic or common databases use instances, while Aurora uses clusters. So just keep that in mind. We want a Postgres instance, of course, so we will have a database instance, which again takes this, then the ID, yeah, it should be fine, and properties. So let's start with the engine. Well, the engine will be that. Okay, so maybe we can define how can we define this database instance engine? Okay, yeah, we have some. MySQL, do we have Postgres? Yes, we have Postgres. Okay, so we use that helper method, which I'm gonna assume takes some parameters, some properties, and the version through which we provide the Postgres version. I'm gonna assume should be something like that. Yes, unfortunately, I think we don't have the latest version, so 13. We should have 12, Yeah, so let's go for the latest version. Cool. Okay, we also provide the PPC, of course. We also provide, so we can configure everything, so everything that can be done from the console can also be done from here, more or less, maybe mostly. So availability zone, choose any of the availability zones. Backup retention, character, okay. Credentials, okay. So for the credentials, this is where we use the secret we just created. We have to transform it a bit, because looking at the type, it expects RDS credentials. So credentials, maybe we can use this to transform our secret. So we use the from secret method and we simply provide our secret, and that should do it. Then database name, no, domain. So we can configure pretty much anything from this. Let's say that we want backups to be deleted. Instance type, okay, this is quite important. Okay, so maybe like this. Okay, maybe not like this. EC2 instance type, EC2 instance type. Okay. Okay. Right. So we can use the auth method, to which we can provide the instance class and the instance size. So the first one would be the instance class. Like that, instance class. And we can choose an instance class. Maybe we want some compute optimized instance or memory optimized instance. We're gonna go for the free tier for now. So let's go with T2, and the size would be micro, of course. Again, stay within the free tier. Okay, anything else for the database? License mode, okay, that looks fine. Option group, parameter group, port, the default port, okay, so that would be the port, that one. Security groups, okay, this is where we provide our security group from above. So no dbsg. Anything else? Multi-AZ process, no. Subnet group. Also we can tell CDK or maybe CloudFormation where to deploy the RDS. So you see, by default it will choose a private subnet and deploy the RDS in that, which is fine for our case. Okay, so that should be all for the database. Then we want to then we want to define the application tier. So we are going to define the auto-scaling group. New, let's auto import that, new auto-scaling group for this stack, ASG, and the properties. So instance type, just like before, let's copy that. Okay, then the machine image. So we are going to work with Amazon Linux 2 AMI. So right now we need the AMI ID of it, and we can find that out by going to the instances. So this is the AWS console, launch instance, and we have the AMI ID right here, Amazon Linux 2 AMI. Okay, we just grab that, paste that in here. Okay, it expects something else, machine image. It should have some methods. So for example, you see it has a helper method for retrieving the latest Amazon Linux AMI. Well, unfortunately it provides this one, not Linux 2 AMI, so that's why we're gonna go with generic Linux and provide the AMI ID. However, each AMI ID, remember, is specific to each region. So for example, this AMI ID is only available in the Ireland region, so EU West 1. If we go to another region, we're gonna have a different AMI ID. So that's why we have to provide a map with the regions. So EU West 1. So this is for me because I work in EU West 1. If you deploy it in North America or somewhere else, you have to change this. Okay, so that should do it. Then the VPC, allow all outbound. Of course, we already did that. Let's see. The name, no. The capacity, we can define the capacity. We should actually define the minimum capacity, and let's say we want it to be 1. The maximum should be 2. The desired capacity, you saw that parameter, it will default to whatever we provide in here, and they also suggest to not provide the desired capacity. Okay, key name, we don't want SSH access. Notifications, no. Role, no. Security group. Okay, you see this is a small detail, but for RDS they expect an array, while for ASG and many other resources they expect a single security group, which of course is fine for us. What else can we define in here? Update type, VPC subnets. Okay, and remember our architecture, we want to deploy in the public subnets. So for that we have to reference our VPC, so the VPC we created above, and let's see if we can get the private subnets, actually the public subnets. Well, maybe it expects, yeah, so let's cut that. Subnet type. Okay, so there are multiple ways to define the selector for the subnet. So this is a selector actually, and we are gonna use the subnet type selector. No, actually we maybe use something else. So subnets, is it like that? Yeah, it's like that. So we explicitly say which subnets to use. Okay, and in this case, the ASG.autoscaling group will create instances in any of the public subnets. If we tell it to create two instances, it will create one in different subnets. It will use different subnets to use different availability zones. Okay, anything else? That should be all. No, not really. So this is important. We need user data, and you might know this. In case you don't, user data are just scripts that we can, or that AWS will execute or run when the instance is created. So remember, this autoscaling group will create instances for us, and whenever an instance is created, we want it to do some stuff. We want it to download our application and start it and install the required dependencies, and we have to provide the user data for it. Now we cannot really provide that inline. We have to define it above. So app user data, new EC2 user data, okay. Yeah, we want to provide user data for Linux. For the options, we can provide the shebang. You see the default one is bash, which is fine. Of course, it's not new because that's a factory. Then let's start adding commands to it. So add commands, and this takes a destructured array of strings. So we are gonna have a few commands we need. I'm just gonna copy them from here. There's no point in investing too much time in this. So for example, we want to install some tools, so update the packages and install unzip and jq and wget. Then we want to install a node. So we are gonna install actually nvm first, which we then use to install node, the long term version, so 12 in this case. And then we want to download our app, so we're gonna use a demo application I built yesterday. It's a very simple one. It's just a node application which stores some quotes in a database and then retrieves a random one. Okay, so we are gonna download it from GitHub. Maybe I'll have a separate video just for this line because it's a quite interesting one and quite useful one. It basically gets the latest release and downloads the zip, which is then unzipped, and we then go into the unzipped folder. This is how the directory within that zip is called. Okay, and then we want to install the npm dependencies and set the environmental variables. We need those to connect to the database, for example. So we have the db user. Let's update that. Okay, right, we forgot to provide here the name. Can we? Yes. So when creating the RDS database, we can provide the database name that RDS will create on our behalf. So in our case, we want to, maybe let's call it quotes. Okay, so database name, of course go for the shorthand notation. Database name, okay. What else? Now looking at this, so we go into the srv directory, just somewhere to place our app and run it. Yeah, we explained that. Unzipped the file, the application, install the production dependencies, so only those. Then set the username, password. This is a very important one and very hard command. It took me like multiple hours to get it right. So we want to get the secret from the secrets manager, the secret we just created above. Now unfortunately we cannot reference it directly in here, so we cannot do something like db secret, I meant db secret value, something like that. It's not gonna work, trust me, I tried. And even if it would work, that would leave our password in plain text, because these commands will be saved in the user data of the ASG, remember, and anyone can read those, which is not okay. So we use the Amazon CLI. Remember, whenever you get stuck, always think about using the AWS CLI, it can do wonders. So we use it to get the secret value. So just provide the name from above, db secret, and yeah, retrieve the password from it. Also the database name, then the host. So the host is provided by RDS, and at this point it's already available. So you see the variable that we defined above, we have multiple properties, one of them being the instance endpoint address, and that's the host that we want. And then set the node environment to production, run the Sequelize migrations and seeds. Sequelize, by the way, is just an ORM for node for relational databases, and then run the application. So that's just script. Is it called a script? Yeah, so something I defined in the package.json of the application. Yeah, it's a script. Okay, so we have the user data, which we can provide in here. Cool. Then we want to define the load balancer. So until now we have this part, we have this part, we have the connection between them, and we want the load balancer. So let's do just that. Okay, so we're going to call this ALB, new application load balancer. Let's auto import that. Yeah, that should do it. So scope, this ID ALB should be fine. Then the VPC. Okay, what else? The VPC subnets. Okay, let's start from the top. Delete protection, HTTP enabled, HTTP2 enabled, true, yes, of course. Internet facing, by default it's false, but we want it to be internet facing, so we want to serve traffic from the internet, so set that to true. Either timeout, IP address type should be fine, so by default IPv4. Balancer name, let's not worry about that. The security group, so ALBSG, okay, and VPC regions. So we want the load balancer to work with the public subnets, meaning that we want it to load balance across our application instances which are deployed in the public subnets. So we are going to basically copy the configuration from above. Yeah, so that should do it. So we have the load balancer. Now we have to configure some things for it. So we want a listener. This is this is what handles incoming traffic. ALB add listener, okay. HTTP listener, okay, and properties, default action. So we want the port, of course. The port would be a number, port 80, of course. Protocol, well, that should be all. Then this listener, can we do something? Add targets. Okay, we want to add some targets to it. ALB app target, something like that, and properties. Well, remember we run our application on port 3000, so we define port 3000. We also have to configure the protocol because it will not be able to infer the protocol. So above, so for port 80 it could deduce that okay, it's protocol HTTP, but in this case we have to configure it. And Of course, it's HTTP. And for the targets, anything else in here? Conditions? No. I'll check. No targets. Actually, it's an array of targets, which of course we can reference the ASG directly in here as the target, and that's gonna automatically allow traffic to go from the load balancer to the application tier, which is quite nice. Okay, let's see, do we need anything else? We need one more thing. So here, if you look at this, well, we have this command which reads the secret, and by default the instance on which the command will be executed is not allowed to basically do anything in AWS, and for certain it's not able to read from Secrets Manager, so we have to allow to grant it access to Secrets Manager. There are multiple ways to do that. The simplest one is to just use the secret from above, and there should be a method grant read. So we want to grant read access to all instances created by this ASG, and that means we want to grant read access to the ASG role. By default, the instances will have this role attached, and that's it. The traditional approach is to define a policy and attach it, and it's quite complicated, but this line is just amazing if you ask me. It's why I think CDK will be quite big, or at least one of the reasons. Okay, so we did that. Yeah, that should be all. So the security group, yeah, we allowed that. For the application security group, we allowed traffic from the ALB security group. Looking good. We can also define outputs. Is it like this? Yeah, it's like this. So maybe, for example, we want to output the application load balancer DNS name. So the DNS name where we can access our application. Giving it an ID, DNS name, maybe ALB DNS name. Okay, and so the value would be ALB DNS name, and that should do it. So we have it. Now it's not gonna work as it is, because when we define AMI IDs, if we search for it, so AMI ID, so we define it for a certain region, and for now our stack is region agnostic. So we want to create it within a certain region, and to do that we should, so going to the bin directory, this is where the stack is instantiated, and we can provide as a third parameter the environment, where we provide multiple things such as the region, and that would be EU West 1. Okay, so that should be all. Now we should be able to run build, so that compiles the application from TypeScript to JavaScript. and we should be able to deploy it. Yeah, so let's do just that. So CDK deploy. Let's see what happens. It's gonna ask us, okay, are you sure? This approval is required whenever the CDK or CloudFormation changes things such as security groups or IAM, users, roles. Remember, we create a role for the EC2 instances to be able to read the secret. Also the security groups we discussed about, and of course we say yes. It's gonna start creating the CloudFormation stack and chain set and all that. This should take like 10, maybe 15 minutes, depending on the stack. In this case, should be something like that. So see you in a bit. Okay, guess what? The deployment is done. So it took not that much. So it started at 126, ended at 135. So 9 minutes, not bad, not bad at all. And if we grab that DNS name, go to the random root, that's something from the application. Guess what? We have our application up and running. And that was all. We have a highly available, highly scalable AWS infrastructure following all the best practices, well, nearly all the best practices, created from the ground up using the CDK. So thank you for your attention. I hope you find this useful, and I hope you enjoyed it. I hope you learned something new. It's my pleasure. My name is Andrei. If you liked it, follow me, give it a like, leave a comment, and see you soon. Thanks. Bye.